Lustre is good at the very high end. You couldn't go for exascale if we would not have kept it. There is nothing better. We did all that job and keep it updated because we know the customers, the users just need it. We also see Lustre in an even broader market, just to use the big data from one of the servers to another, from one machine to another. You need it. So you need it, if you see a pyramid, you need it from the very high end to the broad market, to the enterprise market. It's the tons and loads of data you can shift in a very performant and solid way.
So nothing really moves data like Lustre. You're seeing it consistently in the top 500, these big, massive capability machines, terabyte per second. You're hearing that more and more now, petascale. And it's really providing that kind of level of capability that nothing else can. What is Lustre best for? Really, I think there's three things Lustre is absolutely geared for. One is providing the linear scale-out, high-performance, capable storage applications. The second is providing the ability to manage that data. So you're seeing the advent of HSM and Robinhood and things like that that'll really let you understand and manage kind of a life cycle of a file system in production.
Why Lustre? Oh, so many reasons. Lustre is fast, it's scalable, it's open. If you don't like what's there, you can tweak it. That's what we've done at Indiana. In terms of scalability, we started out, we had maybe 500 terabytes. All in all, we have 5 petabytes now. Who'd have thought? We started with maybe 14 gigabytes a second, and now we're measuring 50 gigabytes a second. So as we have grown, it's grown with us. We're continuing to grow, and we anticipate that Lustre will grow with us. Basically, anything that you can do in a short amount of time can also be done in a long amount of time. That's also a joke.
Why Lustre? It's probably the most scalable, high-performance, open source file system available today. It's providing stability to some of the largest scale computational environments in the world. And we're currently able to store multiple petabytes of data and move data in and out of Lustre at over a terabyte per second at multiple sites, such as the K computer in Japan, Oak Ridge National Laboratory's latest deployment with Titan and Spider 2. It's simply the most capable file system on the market that's open source.
Lustre is an open source file system capable of handling the amount of data we need to offload from Sequoia. Sequoia is our fastest, largest system we've ever cited here in Livermore, and it's currently number 3 on the top 500 list of supercomputers.
So why Lustre? Lustre is the proven technology to move mass amounts of data from rotating disk storage today to compute. Lustre has the land speed record. If you take a look at the K machine in Japan that Fujitsu runs, over a terabyte a second, I think it's 1.2 terabytes a second write, and 2 terabytes a second read per second. This is a mass amount of data. If you've got a big expensive compute machine sitting there, you don't want it starved for data. The way you feed it data is Lustre.
So I was working at Livermore at the time, right? And from our perspective, there had been the killer micro revolution. So I started at the lab in 1984. 1983, graduated with a PhD in numerical analysis from Texas a year later, and I was brought in to work on the parallel processing project, where going 8-way parallel was like, wow, this is like major, So that killer micro revolution led to a lot of innovation in processor architectures and the RISC versus CISC architecture thing. It also shifted the industry from proprietary or home-built, like at the labs. Each of the labs had their own operating system and compilers and all that stuff, right? Home-built or proprietary systems to open systems called Linux. Industry was developing those kinds of technologies, but they were doing it on Unix within their vertically integrated hermetically sealed, you will buy from us environment, and that was great. But the cost performance of commodity COTS-based Linux clusters was so powerful, we had to go in that direction. Otherwise, we couldn't sustain the level of system growth that was required by the applications people to meet their programmatic requirements. When I think of Lustre, the first thing that pops into my head is a global parallel file system that we called the intergalactic file system. I mean, it was such a tall order, and continues to be a serious technical challenge as we grow system size and the bandwidth and capacity requirements increase. And we've done a lot of analysis in preparation for the DOE Exascale initiative and upcoming worldwide procurements that are going from 1 to 10 to 100 petaflops and exascale beyond that. And the phase transition for exascale is as big a phase transition as going from 0 to a new parallel file system. We really do need not only an evolution of the existing POSIX parallel file system semantics, but we need new elements to that, like burst buffer technology, which takes a little bit of stress off the parallel file system by providing a very high-speed flash-based cache on the system at a very high rate of speed. The other thing that we need is that there are new emerging memory technologies, non-volatile memory technologies that are going to get a lot closer to the processor, and that offers some amazing opportunities to change the way that we view and operate on storage. And so we're deep in deep discussions about how to do that, internally at Intel and with the Lustre ecosystem and potential partners. And it's a very exciting time.